Okay, folks, welcome back. That was just a quick one because I spent all that time demoing. Okay, we did have a question about the challenge. Let's have a look. I don't recall this question off the top of my head, so I'll have to familiarize myself with it. So we have an image like this, which shows several polygons and some points. And so let's see what the quiz question is. Just a moment, I'll just pull it up. Okay, here's a question. Thank you, Jason. The image above shows point locations of community centers and polygons of service areas. What will occur if a feature reader is configured to read centers with a spatial filter of intersect using weird? Just reading that question, using the areas as initiators. Right, so this is a question. So feature reader, initiator port is the polygons. The data set being read are the points. What will come out of the output port on the feature reader? The points that overlap the polygons would be what comes out of that output port, because we're using the polygons as initiators, and so it's going to be reading those. Now, yes, exactly. So the question is, does each point get read a single time? And maybe we need to be a little clear about the fact that it looks like these service areas overlap, and I don't know if that's actually obvious enough. Maybe we need to say that explicitly. But from what I can see, these polygons are overlapping. You can see like this one here. I think you can see my mouse. That looks like it's overlapping. Yeah, I agree. It's a bit sneaky to have you try to figure that out. So I think we should explicitly say overlapping service areas, because you can see, for example, this point here would actually be read twice. The initiators are considered individually. So this initiator, this blue one, would be read. This point would get read. And then later on, this orange initiator would be read. That point would be read again. And this is a challenge you'll run into with the spatial filter if you have non-contiguous, is that the right word? If you have overlapping initiators, you can read features more than once. So you basically choose, if that's the case, you often will choose to be a bit greedy on reading, and then you'll have to do a little bit of filtering afterwards. It can still be faster than reading everything in some cases. Or you have to do something like a dissolve or other technique with the initiator before you do the reading. And we'll actually look at that in the upcoming exercise. I understand the output would be in there 2 times, but would everything not be read every time? Otherwise, how would it know what is in or out? I see. Yeah, just from like a performance perspective, how does it not read everything? My understanding is that it's able to do checks just based on the geometry and ignoring all the attributes, and therefore that can just be a bit faster than reading everything in and then filtering. It is a bit odd, right? It does need to know the location of everything. But for whatever reason, I'm not a software developer. It can be faster to do the spatial filter reading rather than reading everything in. I assume attributes probably are part of it. It's just working with the geometry. Maybe there's something else in there that I'm not aware of, but it is more efficient. And let me make a note to mention that these are overlapping, because that is a bit unfair. Yeah, Jason, I think it's related to, yeah, I guess what is reading here. I think it's more of like it does a check for geometry first, and then it fully reads in the feature if it matches, I think is how I would kind of explain it. And that check can be faster than fully reading. Yeah. And then BB, is there an associated feature ID with the selecting polygon to identify why the point is there? Selecting. Oh, I see. Right. Can you tell which feature matched? There is. I forget what it's called. Let me just check. I believe we mention it in the text of this exercise. Under feature reader. What do we call it though? Yeah, matched record. Okay, no, sorry. That tells you how many were matched from the initiator. Do we actually add something? Yeah, so that doesn't quite answer your question. I think this will tell you the number that were matched for each feature. Don't know if we put an ID on there automatically that tells you which initiator was a match. Yeah, I'd have to dig around to see. I'm not sure. I think if you definitely needed that, you might have to read everything in and then actually use a spatial filter or point on area overlayer or something, which can link the features. Yeah. Okay, I need to move on. We've been talking a lot. These are great questions, but I am cognizant of time. So I'm going to demo this exercise here. Have a look at the feature reader and FeatureWriter in more detail. So the scenario here is we have a folder with ortho photos in GeoTIFF format, and we would like to extract those only in a certain area. So we'd like to read those images in, but we want them to just be for this downtown area in Vancouver, which is the example city we normally are using here. So let me go ahead and open up the starting workspace here. I think you probably all have the drill there by now, but so you're aware, we have a starting workspace for most exercises and a completed one for some exercises as well. On these machines, those are located in CFME data workspaces, and then you just have to look at the path to find out where they are in there. So the starting workspace here is advanced reading and writing, and it's exercise use the feature reader. So this one will be the starting workspace, and then if there is a complete one, that shows you the solution, basically the finished workspace after all the steps. You can use that to check your answers, or if you get stuck, to see what you're missing. So this is our starting workspace here. Let's quickly look at what this does. Reads in some polygons. Well, actually, I'll also just run it so we can have something to look at while I'm talking. So polygons of neighborhoods. We remove attributes and reproject. So we're basically getting ready to have this function as an initiator. One thing I would note, just because this came up, I had a question about this yesterday. What's the unexpected input dialog? This shows up if you're reading a format that FME has to read in all the feature types, but they're not all on the canvas. Some formats work like that. For example, KML, the whole thing gets read in regardless of what you tell FME, and it will say, hey, I read these feature types. They're not on the canvas. Is that okay? I find from when I'm working, the answer is always, that's fine. I know what I'm doing. So I just tell it not to tell me. But it can be a helpful warning to make sure you have all the data you need. So yeah, we read this stuff in, the neighborhoods in, we reproject them. We are going to add a feature reader over here. So we've used a dissolver to make sure that we're not reading features more than once. Once we have the features we want, we're going to mosaic them, so turn them into a single image. We're going to clip that to the neighborhoods. We'll do a little bit of raster processing to add transparency where there's no data, and then we'll write out to GeoTIFF. So let's have a look at the steps here. So first of all, let's add a feature reader. And yeah, thank you for that note there about the resource connector. I was not aware of that. Let me, we'll deal with that when we get to it. So let's add a feature reader. And so we're going to use the area output port of the feature reader. So you can see, we start with 6 neighborhood polygons and we've dissolved them into one. This is a technique to get around that multiple reading problem. If we didn't do this, we would read in many of the rasters, or sorry, to read the rasters in multiple times, which is inefficient. So we'll use that as our initiator. Then we have to configure how we'd like the feature reader to work. So we're going to be using a GeoTIFF reader. The data set, I would recommend definitely browsing to the local version of these files because it can be quite slow if you use the web version. And those are located in FME data/data/orthophotos. And so I'll go in here and then I'm just going to hit Control A to select all and then click open. So that will add these in separated by a comma saying read all of the images. But we're not just going to read all of them. We are going to use a spatial filter. So let's put in a OGC intersects, this option here. And so that will read in all of the geotiffs that overlap with, or sorry, intersect with the neighborhoods. So I'll configure that. I'm just going to do a quick save. And then we'll run the feature. If we inspect this, we can see these are just the geotiffs that intersect the neighborhoods. There were, I think there's 30 or 40 something total geotiffs. So you can see we've only ended up reading in 27, which is faster than reading all of them in and then filtering them. This is another example, I think, of Jason of why it might be faster. I imagine we're just using like the bounding box of the raster to check for intersection. We're not actually reading in all of the raster data. And so that's a reason it can be faster. So now we'd like to send those correct geotiffs into the raster mosaicer, and we can run that to see what the rest of the workspace does. So we're basically clipping the raster to the neighborhoods. And so now what we see, we'll have individual neighborhood rasters that are clipped to their boundaries with some no data values for basically like transparency for the areas that aren't covered. And that's just taking a moment to show up. But what I'll do next is add a FeatureWriter. So we're going to write first locally, and then in theory, we're going to upload to FME Flow. We'll see if that works as intended. Yeah, you can see we now have these individual rasters for each neighborhood. That's the goal here. So let's upload these. We'll write them out and then upload them. So first off, FeatureWriter. This will let us write these out locally. We'll keep it in GeoTIFF format and write this to our normal output folder, but I'll make a new folder in here for ortho photos since we'll be writing a couple. So we'll write those out there. And then one thing we'd like to do is by default, these will all be called output. Since we have 6 different images, one for each neighborhood, we can actually set the name of the raster to be the neighborhood, right? By using an attribute name. This is a basically a data set fan out here that we're doing. Could also, I guess it's technically both a data set and a feature type fan out. And so we are calling each raster by the name. So I'll click OK. Let's run this and we'll see locally we should now have 6 raster files with the name of the neighborhood. Oh yeah, that's a slightly tricky one there, Clifford. That question. It's saying without using the dissolver. So try running it without the dissolver and see what result you get. I don't think it would be 27 unless I'm mistaken. So let's open this the folder where we've written it. Yeah, no worries. It's a bit of a tricky question there. So yeah, we can see we have 6 raster files, one for each neighborhood. So now we'll do a conventional use case here for the FeatureWriter. We're going to send this data somewhere. Now that we've written it, you can see in our summary, output port, we have a data set attribute with the folder where the data is located. So let's do something with that. Now, normally we would use the FME flow resource connector, which apparently is deprecated. That's interesting. What has it been replaced by something? Oh, they want you to use a HTTP caller and use the REST API. Okay. We could do that. It would probably take me a minute to figure out how to configure it though, because I haven't used it for that purpose before. So I guess get working on the exercise. I'll go tinker with it and find some new instructions on how to do that with the API. I would think it might require some configuration on the flow side, unfortunately, though, to do that. I'll have a look. So go ahead and work on that up to now, up to this step. You can see basically at this point, though, you can do whatever you want with this folder. Any kind of connector transformer that you have an account for, you can configure and upload this folder there. So the idea is pretty straightforward. But yeah, I'll go and see if I can figure out how to do this with the API. And then, yeah, go ahead and work on that. And, well, maybe take a break first, actually. It's already past 10. Take a 10-minute break. Come back and work on this exercise. I'll have a look at how to use HTTP caller for it and see if we can get that working. And yeah, we'll probably resume around 10:20, maybe a little after 10:23. So yeah, take a break and then come back and work on this exercise. I'll see you in a little bit. Thanks.